Hello and welcome to our lesson on solving logarithmic equations. This is going to be from section 9.6 in our text. In this lesson, we're going to look at two techniques for solving log equations. First, the method of common bases. And if you watch the previous lesson on solving exponential equations, you're going to notice that these techniques are similar. So for the method of common bases, it basically says if you have an equation where you have log base b of x equals log base b of y, as long as those bases are the same, then you could kind of say that the logs are going to cancel and then x would have to equal to y. The other technique we're going to look at is converting from logarithmic to exponential form. Now, before I jump into the textbook examples, I want to explain that there are three categories of problems that we're going to run into. I'm going to sort them as easy, medium, and hard, and I'm going to explain why they are rated that way. First of all, the easy category is an equation where you have only two terms, they both have a log, and the logs both have the same base. So much like our method of common bases, if you have log base 3 of x equals log base 3 of 5, if it's a log equal log and the bases are the same, effectively they can cancel. And look, there's your answer right there. So that is super easy for that particular setup. For the medium category, that would be an equation where you have a log on one side and a constant on the other, and it doesn't matter what side they're on. If you have log base 3 of x equals 5, there's only one term with a log, and on the other side you have a constant, then this is going to require a little bit more work. The medium problems are where we're going to use the technique of converting from logarithmic to exponential form. And so here it's not too bad. We're going to bring the base down, switch the other two around. So the 3, since it's the base of the log, is going to have an exponent when we convert it to exponential form. And the exponent is going to be the 5 that's coming over from the other side. The x goes over to be by itself. And then you can see this is basically solved for. All you would need to do is calculate 3 to the 5th power, and then you're going to have your answer. Now for the hard examples, this is where you have multiple terms in the problem, and one of those terms is a constant. So if you have, several logs, but then one of the terms in the equation does not have a logarithm, then this is going to require even more work than the medium examples. So in the hard case, you would need to use properties of logarithms to convert your equation into a single log, and then you can do the technique that we used in the medium problem. So just real quick, for this particular case, we have addition between two logs. Notice those logs do have the same base, so we can use the product rule that says addition turns into multiplication. And so we can combine the x and the 5x and make it x times 5x. Again, that's using the product rule. And then once you get this down to a single logarithm, then you can bring the base down, switch the other two around, and you can finish and solve for x. So those are the three categories we're going to look at in this particular lesson. Let's jump into our textbook examples. All right, so our first example, number 39, here we have log base 2 of 10 plus 3x equal to 5. All of this stuff on the left-hand side is a single term with a logarithm. On the other side, we have a constant. So this is going to be the setup where we're going to need to convert from log to exponential form. Again, if you have only one log and the other side is a constant, you're going to want to convert. So we're going to bring the base down, switch the other two around. Don't forget that that 2 is a base, so the 5 becomes an exponent, equals to 10 plus 3x. And now that we don't have any more logs, we can solve as we normally would. Now we are going to need to evaluate 2 to the 5th power. I recommend the calculator. Super easy. We can go 2 to the 5th, and that's 32. So we're going to have 32 equals 10 plus 3x. We're going to bring the 10 over. That's going to make it minus 10, which gives us 22 equals 3x. And the last step, divide both sides by 3. And that's not going to reduce, so we're going to leave that effed up. We're going to leave it improper, because that's the way I like it. And we're done. Now, the other thing is you can plug this back into the original problem and check it. And I think I will show that here on the first example, just so you know what the checking process looks like. So to check it, we would say log base 2 of 10 plus 3, and then we're going to replace the x with our answer. And that had better work out to equal 5, or it's not correct. So notice here, using the order of operations, doing in the parentheses first, these 3's are going to cancel, which is going to leave us 10 plus 22, which is 32. And then to check this, again, we can bring up the calculator. And with the Casio, it's super easy to do log base 2 of 32. And we do get 5, which is what it should equal. So that's how you can verify your answer, by plugging it back in and checking it. Now, for our next example, number 43, if we evaluate what we have in this equation here, you're going to see that we have 1, 2, 3 terms in the equation, and they all have a log. So this is going to be one of the easier cases. However, we are going to have to combine these 2 logs into one, and then we can use the method of common bases. So what do I notice here? I notice I've got a subtraction in between the 2 logs. They do have the same base, so that means I'm going to be able to use the quotient rule, which says subtraction turns into a fraction, and whoever comes first is on top. So the x plus 20 is on top, the x plus 2 is on bottom. Notice the 2 logs become 1. That's how the quotient rule works. And now that I've got this condensed into log equals log, remember, as long as those bases match, they'll cancel, and I'm going to have an equation that I can solve with no logarithms. So x plus 20 over x plus 2 equals, and now I'm going to go ahead and say equals x over 1. Now the reason I want to F that up, the reason I want to fraction it up, is because now, notice I've got a proportion. And to solve a proportion, you cross multiply. So we're going to cross multiply to get rid of our fraction. That's going to give us x times x plus 2 equals 1 times x plus 20. 1 times anything is itself. And now I've got an equation that I need to get rid of the parentheses. It looks like I'm going to have a quadratic here. So using the distributive property, that's going to give me x squared. That means quadratic, which means I need to set it equal to 0. So now I'm going to go ahead and bring the x and the 20 over so that I can set it equal to 0. I do need to combine my like terms so that we get our quadratic equation in standard form. And then remember, the easiest way to solve a quadratic, if it will factor, is factoring. So let's take this trinomial and F it up. Let's factor it up. If I read the signs, it says the signs have to be different. We're going to have an x and an x to make x squared. And the numbers that multiply to make 20, that subtract and make 1, are 5 and 4. So now that this is factored, I can set each factor equal to 0 and solve. Moving the 5 over gives me x is -5. Moving the 4 over gives me x is +4. Now, just for some good math advice here, if you're solving a logarithmic equation and you end up with two answers, about 90 to 95% of the time, one of those answers is garbage. That means when you plug it in, it's not going to work out. And it's usually the smaller answer. So the -5 is probably going to be no good. And we're going to see if we can verify that by checking. Okay, so you do need to check these logarithmic equations, especially when you get two answers. All right, let's check it out. So we're going to have, plugging back into the original equation, log base 2 of -5 plus 20 is 15. Remember, I'm checking the -5 first. So plugging the -5 back in, -5 plus 20 gives me log base 2 of 15, minus log base 2 of -5 plus 2 is -3. Now that is a red flag. Equals log base 2 of, remember, every x gets replaced with -5. Whoops, and again, that is a red flag. Now, what does that mean by a red flag? What that means, it means that anytime you end up taking the log of a negative number, that's not going to work. Okay, make a note of that. You cannot take the log of a negative number. So this is not going to check out because this gives us, well, either an error on the calculator or an undefined situation. And so that means that -5 is not going to be a solution. And we probably do need to go ahead and check the +4 just to make sure that it's not no solution, because that is also possible. So checking the +4, plugging it back into the original equation, that's going to give us log base 2 of 4 plus 20 is 24, minus log base 2 of 4 plus 2 is 6, equals log base 2 of 4. Remember, we're plugging 4 into every x into the original equation, and then we're going to use our quotient rule to simplify. That's going to give us log base 2 of 24 over 6 equals log base 2 of 4. And what is 24 divided by 6? 4 times 6 is 24. That's going to simplify to log base 2 of 4 equals log base 2 of 4. And obviously, those are going to work out and be equivalent. And so what does that mean? That means our answer is 4, and that is the only correct answer. You would not include -5 in your solution set. All right, next example, number 53. Again, if we evaluate what we're given here, we have 1, 2, 3 terms, and they do not all have logarithms. So this is going to be what I would consider one of the harder examples, where you're going to have to combine your two logs and then convert to exponential form. I would like to remind everybody at this point that if your log has no base showing, remember that is understood to be base 10. You don't have to write it. I'm writing it just so you know that that is a base 10 on our log. Now then, our two logs are attached with subtraction, so that indicates the quotient rule. So when I put my two logs together, the subtraction turns into a fraction, where the 2x plus 1 goes on top, the x minus 2 is on bottom, and that's still going to equal to 1. And I am going to put that 10 back in there. You know why? Because now that I have the equation simplified down to a single logarithm, I can now convert to exponential form. And how does that work again? That says bring the base down, switch the other two around. And so that's going to give us 10 to the first power, but obviously anything to the first power is itself, so 10 to the 1 is 10, and that's going to equal to the rational expression, 2x plus 1 over x minus 2. And since we now have a rational equation, we can solve for x by multiplying both sides by the common denominator, which is x minus 2. That's going to get rid of the fraction, and the 10 is going to need to distribute. So 10 times x is going to give us 10x. 10 times negative 2 is negative 20, equals 2x plus 1, because the denominator canceled. And then it's basically 2 more steps and we're done. Let's move the 2x and the minus 20 so that we can get our like terms together on the same side. Don't forget, when you move stuff over, you have to change the sign and then combine like terms. We're going to get 8x equal 21. And for the last step, we're going to divide by the coefficient of x, and that gives us x is 21/8. Now that is an improper fraction, and I prefer those. Let's leave that improper. And again, remember, if you want to plug that back in and check it, you can. So I think what I'm going to do for a special treat is show you how you can use the calculator to check more efficiently. That means you can save yourself a lot of manual labor if you know how to use the calculator correctly. So what we can do to check this is we can replace every x with 21/8, calculate the left-hand side, and see if it equals to 1. Okay, here we go. We're going to use the log by itself, shift and negative. Remember, that gets the log base 10 without having to use the log base button. Log of 2 times 21/8 plus 1. Now notice that is this term with x replaced with 21/8, and then I'm going to say minus log of 21/8 minus 2. 21/8. Don't forget to move over and put your minus 2, close parenthesis, and bam! Notice that that gives 1, which it should if this is the correct answer. And so again, that's just a way that you can use your calculator effectively to make your checking more efficient. All right, next example, number 55. Here again, if we take an inventory of what we've got in this equation, we've got 1, 2, 3 terms. Notice they all have a natural log. So this is going to be super easy, but I do need to point out one thing that's a little bit different, and that is that this natural log has a coefficient. In order to use the method of common bases, your logs cannot have coefficients. And so we are going to need to make use of a couple of properties of logarithms here. First of all, notice that these two logs are separated by addition. So we're going to want to use the product rule to combine those into a single log. And the most effective way to get rid of this coefficient is to use the power rule. So remember, for logarithms, you can take the coefficient up and it becomes the exponent of what you're taking the log of. So we're going to be using the product rule and the power rule in order to solve this equation. Here we go. So the natural logs combine and their stuff gets times. That's how the product rule works. On the other side, we're going to have natural log of x squared using the power rule. Now notice we have only two terms that both have natural log. And so those natural logs can cancel, and we won't have any more logs left. Now we are going to need to use the four-letter F word here. Yeah, we're going to need to FOIL it. Let's F it up. X times x, x squared. On the outside, minus x. On the inside, plus 8x. Last but not least, 8 times negative 1 is negative 8 equals x squared. Now, if I minus x squared from both sides, those are going to cancel, and that's actually fantastic because now I don't have a quadratic. Now I just have a linear equation. It's going to be much easier to solve. Combine like terms, we're going to get 7x equals, moving the negative 8 over makes it 8. And if we divide by 7, we're done. X is 8/7. Another improper fraction. Fantastic. And remember again, you can plug that back in and check it if you want to. All right, our last example in this lesson, number 57, and here I did save the best for last. Let's look at what we've got here. We've got 1, 2, 3 terms, and they do not all have a log. So this 1 being a constant is going to make this a little bit harder. Notice also that the logs are not on the same side of the equal sign. So in order to combine them using the properties of logarithms, we're going to need to move a term over. So that's going to be our first step to solve this problem. We're going to need to bring this negative log base 6 of x plus 5 to the other side. So that's going to give us log base 6 of x plus log base 6 of x plus 5 equals 1. Do you understand what I did there? I brought the log over so that both of the logs are on the same side. And now I can use the product rule to combine these logs into a single log. All right, so here we go. Using the product rule is going to give us log base 6 of x times x plus 5 equals 1. And now that I have this simplified down to a single log, I can now convert to exponential. We're going to bring the base down, switch the other two around, and I'm going to distribute on the fly. That means as I'm switching it around, I'm going to go ahead and use the distributive property. So the 1 becomes the exponent. 6 to the 1 is 6. Equals x squared plus 5x using the distributive property. Uh-oh, did you see that x squared show up? You know what that means? It means that this is now a quadratic, which means I have to set it equal to 0. So we're going to bring the 6 over. We're going to set this equal to 0. And then I'm thinking we're going to solve this quadratic by factoring. I think it will factor. Let's F it up. So the signs are going to be different. We're going to have x and x to make x squared. And the numbers that multiply to make 6, that subtract and make 5, would be 6 and 1. And now that that's factored correctly, we can set each factor equal to 0 and solve. And bringing the 6 over gives us x is negative 6. Bringing the negative 1 over gives us x is positive 1. So we do get two solutions. If you remember what I said earlier, I said most of the time, not always, but most of the time, when you get two solutions for a logarithmic equation, one of them is usually garbage, and it is usually the smaller answer. So what we need to do is we do need to check both of these solutions to make sure that the negative 6 really doesn't work and to make sure that the 1 really does work. And also remember, when you check these answers, you do need to go back to the original equation and replace every x with the answer you're checking. So we're going to start with log base 6 of, we're going to check the negative 6 first. So log base 6 of negative 6, replacing this x right here with negative 6, and I don't need to go any farther. Remember, that's a red flag because you can't take the log of a negative number, and so that answer is definitely not going to work out. It fails immediately. Okay, next we need to check the positive 1 and make sure that it really does work. So we're going to have log base 6 of 1 equals 1 minus log base 6 of 1 plus 5. 1 minus log base 6 of 1 plus 5 is 6. And so I can go ahead and simplify that. When I replace this x with a 1, 1 plus 5, I can go ahead and make that a 6. Now, what is log base 6 of 6? Well, if you think back to previous lessons, we said if the bases match, they cancel, and the exponent is the answer. And so the right-hand side is going to simplify to 1 minus 1. On the left-hand side, we're taking the log of 1. And again, if you think back to previous lessons, I said no matter what the base is, if you're taking the log of 1, that answer is 0. And 1 minus 1 is 0, and that checks out. And so the only acceptable answer here, the only correct answer is 1. And that is going to do it for that lesson. So if you have any questions or comments about anything I've done so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.